So when talking about atoms, we must understand that every element has a symbol. For example, C stands for carbon, whereas AU stands for gold. Now you may notice here that C is the first letter of carbon, so it works to be the symbol. However, AU is not the first letter of gold. So why does AU represent gold on the periodic table? This is because AU are the first two letters of the Latin word for gold. Some other elements on the periodic table also take this pattern. So, when talking about atoms, there are differences between an element, a compound, and a mixture. When you have an element, this is when there is only one type of atom. So this may be magnesium or O2. So even though there is a 2 here, which would represent a bond between the two oxygen, it's still only one type of atom. Whereas, if I were to take this, for example, where we've got 2 hydrogens and an oxygen, compared to just the 2 oxygens, this is a compound. This is because there are 3 different atoms here. Even though these 2 are the same, there are 2 of those and 1 of these. So this makes for a compound due to the fact that there are more than one type of atom and they are chemically bonded together. So even though here with the 2 oxygens, these are chemically bonded together, because they're the same atom, they only count to be an element. So, in order for this to become a mixture, what happens is a mixture is actually when a substance contains more than one element and or compound. The difference is these are not chemically bonded. So to put it as a diagram, a mixture. For a mixture, what we would say is you've got those 2 elements, got those 2 elements, you've got that element, and you've got that compound. So as you can see here, this is a mixture of different things. And we say this because we haven't just got this compound. We haven't just got these elements. It's a mixture of the elements, the compounds, all of it together. But the elements aren't chemically bonded together. The elements aren't chemically bonded to the compounds, and nothing's chemically bonded. So that is what makes a mixture. So when you then go on to talk about the conservation of mass, the conservation of mass means that no atoms can be created or destroyed. This is the same as the conservation of momentum, for example. So, when you've got the conservation of mass, that then leads us on to the next point, balancing equations. So here, if we use this as an example, CH4, which is methane, add O2, which is oxygen. This then makes CO2, which is carbon dioxide, and H2O, which is water. When you've got these chemicals in an equation, it's not balanced. Because if we take a look up here, we've got 1 C, 4 H's, and 2 oxygens. Whereas down here, we've got 1 C, 2 oxygens. No, there are 3 oxygens. 3 oxygens. And there are 2 H's. So in order to balance this equation, we must make sure that we have the same number of O's, same number of H's, and same number of C's on both sides. So as you can see, we already have the same amount of C's on both sides, whereas the H and the O are not the same. So, in order to fix this, we must make the O's up here equal to 4, and the O's down here also equal to 4, and the H's down here must then also equal 4. So to get to this point, we've got to put a 2 in front of the 2H2O, because we cannot change these small numbers. These are unchangeable. We can only add the larger numbers, or the coefficients. And then for this top section of the equation, we've got to put a 2 in front of the O2, because once again, we cannot change the little number. But by putting a 2 here, this means we've got 4 oxygens now, because we've got 2 lots of the 2 oxygens.